Okay, here I just want to do several examples of graphing quadratic functions in this form now. So let's look at this first function. Okay, we're going to graph this function using symmetric points, and we're going to start by making the part that's squared 0. So that will give us the vertex. So to find the vertex, I'm going to look at when x is negative 4. When x is negative 4, this is 0 times 1/3 is 0, so you just end up with the negative 2. So negative 4, negative 2 is the vertex of this function right here. So we can actually go ahead and determine our axis of symmetry here. It's through the vertex, so the axis of symmetry is the equation x equals negative 4 if we wanted that. Now I need to find some symmetric points, so I'm going to go one to the right of my vertex and one to the left of my vertex. So I'll look at when x is negative 5 or negative 3, they're going to give me the same y value because they are symmetric. Y would be, if I plug in the negative 5, this is negative 1, but I square it, I get a positive 1. So I end up with 1/3 times 1 minus 2, and that's 1/3 minus 6/3, which is negative 5/3. Negative 5/3 is negative 1 and 2/3. So to plot that, I need to first find when x is negative 5 and y is negative 1 and 2/3. So negative 5 is right here, negative 1 and 2/3 is right here. And then when x is negative 3 also, I have the same y value, so I get the symmetry here for my parabola. Let's find one more symmetric point. Let's go 3 to the right and 3 to the left. So that would be an x value of negative 1 and 5, 6, negative 7. So negative 1, negative 7. They're going to be symmetric, so I can find my y values here. So if I plug in negative 1 or negative 7 here, it's going to give me a 3 squared, which is 9. So I end up with 1/3 times 9 minus 2. 1/3 times 9 is 3, minus 2 is 1. So if x is negative 1, y is 1. And if x is negative 7, 5, 6, 7, y is also 1. And so you can see this parabola is fairly wide. So this parabola opens upward because the number in front here is positive. The vertex is negative 4, negative 2, pretty easy to see that. We got our symmetric points, we've got our axis of symmetry. This parabola is fairly wide because this number is so small, so the points aren't growing very big as you go to the right and left. Okay, so let's try another example. So in this example, it might be useful to think of this function as being negative, and you could say x minus 0 squared plus 4. So there's nothing here being added or subtracted from the x, so you could write it this way. And so now you can see that the vertex would be when x is, well, what x value makes this 0? Well, of course it would be 0. So when x is 0, y would be 0 squared times the negative is still 0 plus 4. Y would be 4. So the ordered pair 0, 4 is the vertex in this case, which is up here. And then symmetric points, we'll go 2 to the right and 2 to the left, let's say. So that would give me an x value of negative 2 and positive 2. Y would be negative. I'm going to plug them into this first version up here. If I plug in negative 2 for x, negative 2 squared is 4. If I plug in positive 2 for x, positive 2 squared is also 4. So I end up with negative, the 4 now, plus 4, which is 0. So if x is either one of those, I get a y value of 0. And if I wanted to now, I could find more symmetric points, but we get the idea. The axis of symmetry here is the y-axis, in fact, which could be described by the equation x equals 0.